Assalamu alaikum dear students. Welcome to my channel KI Corners. In this video I'm going to teach what is the integration. Before starting our lecture, I would like to know, dear students, have you investigated before application of integration? Why do we use integration? Just we are like limited. Just know how to solve. I don't want just just only solving. I know you are good in solving, but you must know its application too. So now I'm focusing why do we use integration, and hope I will uh, explain you and you understand through daily life examples. So by the way, what's the application, and why do we need integration method? So first of all, I would like to tell you who is the founder of calculus. Actually, integration is a part of calculus, and calculus consists of integration and differentiation. So we know who's the founder of calculus. Two giants, are one is Newton and Isaac Newton, and second one is Leibniz. But I want to tell tell you that before Isaac Newton and Leibniz, Archimedes actually he was trying to calculate area of circle, and he wants do uh, make different polygons of circle. Inside the circle, actually he wants to make a different sections of circle and then calculate area of circle, and to calculate a value of pi as well. So anyway, we now we know integration is a part of calculus, and integration means sum. And what's the application in daily life? Suppose I have a glass. Suppose now is a complete form. This is a glass. If by mistake, I did mistake. Suppose, oh yeah, yeah, or slip from my hand this glass, what will be happen? This glass will be broken. It's understood. But what's physically, how can I interpret, this integration in this situation? So now what I'm doing here, actually I'm disintegrating, actually, breaking into different pieces. This glass will be broken into different pieces. This is we're doing disintegrating. This is a differentiation. So now how can I come back to integrate? So I collect the pieces of glasses, and then join these glasses through glue or XYZ, your Alpha with through Alpha, XYZ, and then combine these pieces of glasses, and then you see, oh, this is a glass. What I'm doing, actually, I want to explain what I'm doing actually in daily life. Suppose I want to know information, complete information. So how can you get a complete information? Definitely you have a one piece of information, then you can guess like a spy. So I have a one piece, and then I can say, oh, it's made of silica, SiO2. Maybe it can be produced through this bit of glass. Maybe we can produce your manufacturer produce a glass of which I can we can drink water. Maybe this bit of piece information, bit of information, maybe tells you, oh, maybe it was a glass, it was a jug, it was maybe some other things can be possible. So now we collecting, accumulating the informations. As you are collecting the information, you will find, or you will you know clearly, oh, this is a glass. Actually it was a glass, now it's broken. So now, okay, now I'm going to give you another example. So in organization, a laborer gives information to supervisor, supervisor gives information to CEO, manager, and manager give information to his or her CEO. So actually what's going on, actually integration of information of of the same company. So actually in daily life is going on, but we don't know it's integrating. It was integrating, actually this now we are assembling the machine. This also integrating the parts of the machine. So I think you understand. I'm giving you some essence of what's integration. Okay, I hope you understand. Anyway, so we can use integration. It can be used in to find area or volume. So you want to know area of a function, you have to integrate a function for one time. Those this is, you will find area. So how do you get a volume? So you do twice of you apply twice, and then you will get volume. So say area, for area is a single integration, for volume is we do double integration. So now graphically representation of integration. So actually we do in I know a lot of students study physics and in different subjects, and you use observation table. So actually you can apply there. So one example is for a physicist, you applying, suppose you have a specimen, you want to test bending test of this specimen. And now you're going to know its bending properties. So you do 3-point bending test, supposedly 2 nodes, and then you apply on top, you apply load, and then you see as you applying load, and this material going will bends, so will be bend, will be bending. So so you'll see graph as you apply force and then give distance. Distance means say bending, and here, suppose you want to know a fracture energy. Actually, I want to know how much energy to to how much energy required to break this specimen. Actually, civil engineer, most of civil engineers already familiar with, even the mechanical engineer as well. So you apply force, and then you see bend, and then you work at point, this material will be broken. So you want to know at this point how much energy. So you calculate area of the area of area under the curve. Actually you want to calculate area under the curve, and then if you calculate its area, and then you I need this amount of energy, then I can break. So how? So we can understand this way. We know work done is equal to force into distance. The work done is actually an energy, and you know what that is? Joule. So and work done is the force into distance. So now on y-axis is force and x-axis is distance. We multiply force into distance is area. Actually, what's the area? Actually, suppose you have a rectangle, is one length is L and breadth is B, and how can you get the area of this rectangle, length into breadth? This is area. Okay, now the area is the same like in irrigation, same as. So you know multiply 4 and this you know this area shows actually energy. So this is the interpretation. So you can apply not only in this case, you apply in many cases. You are, suppose you have curve y and x. You want to know area means it means the force into distance, and you suppose also reaction rate. You can apply how much need concentration so to react your sample. So reaction starts, reaction will be started. So this is a first lecture. Now I'm going to end now. I hope I will continue this series of lecture on integration. So I know you understand what's integration, and I want to know just you study at home and you find calculus a part of integration and differentiation, and you practice by yourself some problem. I know you did it, but practical. You find practical examples at your home, and then you need any help from my side, I can help you. Thank you for watching.